delta H sub F is the energy involved in the formation of how much? 1 mole. 1 mole. 1 mole of what? Compound. Compound from its elements. Those elements must be in their most stable state. So we will make this from the elements 4 carbons and 5 H2. Hydrogen is diatomic. Now Hess's law has told us that if you can come up with 2 or more equations that when added together they will equal the equation that you're looking for the heat for, then you just have to add the heats of reaction of those together. So the first thing, if I go to the table of heats of formation, which obviously if we're trying to solve for it, it's not there. So it must be on the table of heat of combustion. What page is that on?
859.
8 which?
I don't know the exact page. I thought it was like 859.
856. Okay, please go to page
862.
856.
No, I'm wrong.
Go to page. Now, is the heat of combustion at the top? Yes, it is. And here's what I know. If you are doing combustion, butane is reacting with oxygen to produce carbon dioxide and water. But if I'm going to add things together to get this, which side of the equation must the butane be written on? Which side is it on right now?
The right.
The right. So I need it on the right. But if I'm doing heat of combustion, it's on the left. So therefore I need to reverse that reaction. And when I reverse the reaction, what do I do with the sign? Change the sign. If you're going downhill, when you change direction, now you're going uphill. So what I'm going to do to speed this up, I am going to put on this side C4H10. Now, so therefore if we were running it this way, it would be combustion. And it would react with oxygen to produce carbon dioxide and water. Now I still need to balance it, so I will put a 4 in front of the CO2. I will put a 5 in front of the water. That will give me 8 plus 5 is
9.
13. So therefore, what I will do is 13 halves. Now some of you might prefer to do 6 1/2, but okay, I'll do 13 halves. Now delta H for this reaction, it's not going to be a C there because it's not combustion, it's the reverse of combustion. It's going to be a positive, what's the value? I changed the sign, what's the value?
2877.6.
Kilojoules per mole. Kilojoules per mole. Okay? I've got one of the compounds. Now I need to get rid of carbon dioxide. Okay? So I can easily do that by making carbon dioxide on the right. Now go to your table of heats of formation. Thumb forward about 4 or 5 pages.
That's 862.
And it will react with carbon plus oxygen to produce carbon dioxide. And delta H is it a negative 393.8?
0.5.
393.5 kilojoules per mole. Okay, now I'll come back to that and multiply through by 4. Why? Oh. Now I need one to get rid of the water. And that water is in the form of a liquid. So if you go back to the table of heats of combustion, there's a footnote telling you that that water is a liquid. There's a footnote telling you that water is a liquid. So therefore we're going to make water, but it's going to be water as a liquid, not as a gas. And we will use H2 plus 1/2 O2 for that. Now delta H will be, is it 180 something?
No, it's 285.
285. And so it's a negative 285.8.
8.
Oh, there's where the 8 came in. All right, so I'm ready to add these together. Now, I need 4 carbons, or I need 4 carbon dioxides. So I'm going to multiply through this equation by 4. 4 moles of carbon, 4 moles of oxygen, 4 moles of carbon dioxide, and that means it'll be 4 times the energy. Is there a question about that? Okay, you understand why I multiplied by 4? Because if you don't, you need to ask right now. Okay, now, on the water, I need 5 moles of water, so I'm going to multiply through by 5. 1/2 times 5 is
2.5.
2 1/2, okay? And then I'll have 5 moles of water, okay? Okay, so I'm now ready to add this together. We're going to add that together. And if we can add these 3 together to get that, then all we have to do is add, I need to multiply, forgot to multiply this over here by 5. Sorry. And so all I have to do is multiply by 5, multiply by 4, add, and I will have it. So let's see if it will cancel out to give this equation. Tell me one thing. Now, this is like canceling like terms in math class. What's on the left that's also on the right?
The 5 H2Os.
The 5 H2Os. Okay, there's 5 H2Os, and there's 5 H2Os. Okay, is there anything else that will cancel out?
4 CO2.
The 4 CO2s. 4 CO2s, 4 CO2s. What else will cancel out?
The 4C, like the C4.
All right, now, what's 4 plus 2 1/2?
6 1/2.
6 1/2. And is 13 1/2 6 1/2? Yeah. Uh-huh. And so that cancels out, and that cancels out.
Don't
Oh,
forget
and the other one, yep. Okay, so
the H.
nothing else will cancel out. So I then bring my 4 carbons down, yes. Bring my 5 hydrogens down, yes. And bring my 1 butane down, yes. So now all I have to do is add all of this together, and it will give me that. Okay, okay, any questions?